Pi Top Seed, the $99 Raspberry Pi desktop anyone can use. Pi Top Seed has a 13.3-inch HD screen and a 180-degree hinge for a wide range of viewing angles. The front-facing acrylic slice gives you easy access to your Raspberry Pi and circuitry.
Once you plug in your Pi Top Seed, you gain access to a world of free maker resources, starting with your own built-for-makers, by makers operating system, Pi Top OS. With Pi Top OS, you can easily connect to Wi-Fi, change your screen brightness, customize your desktop experience, and download a huge range of Raspberry Pi resources. And yes, you can even play Minecraft.
Pi Top Seed isn't just about having a great way to use Raspberry Pi. We're committed to providing free and fun learning resources that teach you how to code and build hardware from day one. Seed Universe is an online game you can play with friends. In this open-ended world, we break down the complex technical aspects of making into fun quests. Connect a breadboard to your Pi Top Seed and learn how to create circuits that will help you in gaming. Don't have a breadboard? Don't worry. We also emulate key hardware components so you can learn how to make without all the bits and pieces.
Seed Universe isn't the only bit of learning software available. You can also access all of these great resources and more. You can even create Word documents and Excel spreadsheets using LibreOffice.
My co-founder and I started with a goal: to make computing education awesome. So we set about creating PiTop in my living room. Our small budget defined our affordable philosophy to computing. We built a desk that we built our 3D printer on that we used to print out the first PiTop prototype. Thankfully, we came to Indiegogo and were funded in just 48 hours. We've now grown our team and moved out of the living room into offices in London. From nothing, we have now traveled around the world to make thousands of PiTops and successfully delivered them to over 47 different countries.
We learned a lot when producing PiTop, but importantly, we developed our production line and supply chain, and we can now make thousands of devices a month. As a thank you to our amazing community and everyone on Indiegogo who helped make this happen, we are now ready to offer you PiTop Seed at $99, a price that will never be seen again except for in this campaign.
We'd also like to announce our partnership with Into University, an amazing organization that provides local learning centers where young people from disadvantaged backgrounds are inspired to achieve positive outcomes and attain a place at university. If you'd like to support this fantastic organization, for an extra $50 you can buy a second PiTop Seed and have that device gifted to Into University to help further these young aspiring students into higher education.
I'm a genius. I'm a genius.
We started PiTop to make affordable technology anyone can use to learn, play, and create awesome things.
So back us today and let's make this happen together.
We love this stuff, and this is kind of this. We love to pretend this was the dream when we started Raspberry Pi. The dream when we started Raspberry Pi was to get kids coding again.
These are Sassy and Asher, and they'd like to present to you the Plusberry Pi. It's a new case for the Raspberry Pi with some built-in features that make it much easier to use. It's not by accident that these two came up with this innovative idea, as they both just love things that are neatly packed in tiny little boxes. But ever since they came across the Raspberry, things got a little messy.
You like sound. You want sound. You got some sound sources and now you want sound. You have microphones and you want to be heard loud. Perhaps you got turntables all old and round. Now you got connectors and now the system of sound. Let's reflect on this. Let's inspect the list. A Raspberry Pi, let's inject into this. We ask the question, what does it miss? An audio injector sound card, add that to your list. The audio injector lets sound straight through. So if you want unaltered setup, this it can do. The input of sound, it's spread all around. To Wi-Fi disk, HDMI, possibilities abound. The output of sound, it comes from all around. From Wi-Fi disk, oh my, where will it resound? Heard you like processing, we run it red hot. Take audio in, process it, spit it out, what you got? The audio injector sound card, get it while it's hot. Live now on Kickstarter, that's our first shop. Oh, did we mention it lets you keep stacking? So your personal add-ons and hats you can just keep racking. I'd like to thank you for listening to my presentation at Flatmax Studios. We're all about
I'm Alex
innovation.
Eames from Rasppi.tv and Raspio. I'm here today to show you the brand new Raspio Analog Zero board, which fits any 40-pin Raspberry Pi. The Raspio Analog Zero is a Pi Zero sized board you can use with GPIO 0 to read up to 8 analog inputs at once, make a weather station, a digital thermometer, a voltmeter, use potentiometer dials for control and display, read analog sensors or voltages, or you can even make your own embedded device with minimal footprint. Ben Nuttall and Dave Jones have done a tremendous job with GPIO 0, making it easy to do useful things in very few lines of code. In just 4 lines of code, you can read and display the voltage on one of the analog inputs. GPIO 0 is now part of the standard Raspbian distribution, so you won't even have to install anything in order to use your Raspio Analog 0. It has a 54-point prototyping area with plenty of power and ground connections where you can put additional components. The GPIO ports are also accessible via clearly labelled through holes. As usual with Raspio products, there'll be some very clear and easy to follow instructions to get you started and show you how to use it. The better this campaign does, the easier it is to justify spending more time on these to make them really outstanding. What about the rewards? Well, apart from the Raspio Analog Zero board itself, there's a few other packages I put together to tempt you with. One of my early Pi projects that I really enjoyed building was my weather station. I've made up 2 weather station bundles, both include 2 temperature sensors, 2 light sensors, 20 male to female jumper wires, and a character LCD. I've also put together a kit of parts to enable you to tinker with GPIO 0 using your Raspio Analog 0 board. So if you like the look of the Raspio Analog 0 or one of the project kits, please consider backing one of the rewards. This Kickstarter's only going to be running for a few days, and we plan to get these out of the door as soon as we possibly can, possibly even break some records in the process. We'll have to see.
Let's talk about programmable RGB LEDs, otherwise known as pixels. Pixels come in 2 primary types: dumb pixels that require a control signal for each of the colors, and the strip has the same color across it. Useful in some cases. Smart pixels allows for the control of each individual LED and its colors. You can have one blue, the next one red, one flashing, one solid, and so on. These types are generally known as the WS2811, WS2812, and 12B. The timing protocol is rather specific as expected. You need something like a microcontroller that can generate those control signals. A few years ago, a small single-board computer arrived, or rather exploded on the scene, and cost around $35, called the Raspberry Pi. Its low cost and general availability put it in the hands of hobbyists and developers. It runs as a Linux operating system and gives us lots of general-purpose I/O. It also gives us, on the 2B and the 3B versions, 2 PWM, or pulse width modulation outputs. That's important because remember, the pixels require specific timing or else they may not operate as expected. A lot of people thought, hey, this might give us a low-cost method of driving the pixels rather than using a full-blown computer. But the timing was an issue, so one day a very brilliant engineer, Jargarf, who I have the pleasure of working with, coded up a method of using the PWM outputs, plus some other clever coding tricks, and allowed the Pi to drive the pixels and on 2 different channels nonetheless. The thing is, the pixel controls are 5 volts. The Pi puts out 3.3 volt signals. Some have been able to drive the pixels directly, but it may not work each time. There's the issue of physics and thresholds and such, but we won't get into that. What you really need is convert the Pi 3.3 volts to 5 volts. What about driving over long distance? You may not want the Pi sitting where your pixels are mounted. So the Pixel Pi board. It plugs right into the Pi. As you can see, there's a number of different connectors, so let's talk about what we have here. First of all, power. Well, the Pi gets its own power from this connector right here. And that's fine. We plug in just a standard USB cable into there that they suggest. The 5 volts for the Pixel Pi board comes in two different places. You can have a barrel jack right here from the standard power supply that a lot of people are used to, or this 2-pin removable header. This is what I prefer for a lot of projects because it gives you the ability to plug and unplug high current power supplies. The incoming 5 volts is protected on the board by a resettable fuse. This USB jack here is to drive 5 volts out to another device, perhaps the Pi. Across the bottom, we have RJ45 jacks. Now you're thinking we have 4 jacks, but we only have 2 channels of output. Well, we split them into channel 1 and channel 2. Each of the outputs is split again, so we actually have 2 identical strings coming off here, 2 off here, again 2 and 2. Well, that's great, but what do we do at the other end of that? And we use Cat5 because Cat5 Ethernet cable is cheap and plentiful. You can get it from a number of sources. You get it pre-terminated. You don't have to worry about crimping your own connectors on there. Just a good cable to use. On the other side here, we have 2 other connectors. And those connectors are used to be able to drive out pixels directly from this board, pixel strings. That's kind of used as a test, but nothing says you don't have to have your strings 20, 30, 40, 50 feet from your controller board. Gives you the options. Also because maybe you don't want to drive this with a Pi. Maybe you're interested in driving it with your Arduino or a PIC microcontroller. We have 3.3 volt regulator on board here, not populated in this case, that will allow you to bring the 5 volts in, give you 3.3 volts on the output of this connector to where you can drive another device and connect it in. Gives us options. So, what do we do at the other end of these cables? We got to cut off the end and strip off the wires? No. That brings us to the endpoint. This is an endpoint. So you can see that the Cat5 cable plugs one side, power comes in, and a pixel strip is connected. So here we have the Pixel Pi plugged into the Raspberry Pi, and you can see the blue LED on indicating that we have power. By the way, that LED is after the fuse, so if you have no LED, it means you probably got a short somewhere and that fuse is blown. It will reset itself, given a little bit of time. We have Ethernet cables plugged in. We've got a short 3-foot piece. We've got a 50-foot length. We have a 75-foot length, and we have a 100-foot length. Simply just to demonstrate the fact that we can drive over long distances. Now remember, Jer Garf had written that underlying code to run on the Pi to drive out pixels directly. Well, some guys created this Falcon player, and it runs on the Pi directly. It brings up this nice web page, and it uses that underlying code that Jer wrote in order to drive out these WS28XX pixel strings. It does a number of other type of pixel strings as well and different interfaces, but I'm using this to just show a demonstration because it's a nice piece of software, very well written. If you're planning on using the Pi with this, you may want to take a look at this piece of software, Falcon Player. So the Pi is networked to my laptop. Simply go into Input Output Setup, Channel Outputs, Other, and it will tell you bring up other outputs. You can add, and it's the RPI WS281X. In the output setup, you set up for string number 1 and string number 2. You can set up the order and the number of pixels and the number of channels. Remember, each pixel is actually 3 channels: the red, the green, the blue. So I'm setting up string number 1 for 10 pixels and string number 2 for 15 pixels, simply to demonstrate the fact that we have 2 different strings running on here from 2 different control outputs. You go over to Status Control, Display Testing, and you can enable the test mode. There's other things in there to set up: start channel, end channel, patterns, things like that. We'll leave that alone for right now. We'll just enable test mode. Hey, look at that. We have 10 pixels and 15 pixels running. from the two different channels. Now remember, each pixel will redrive the output. And so the only pixel you have to worry about driving is that first pixel. Once you get to the first pixel, the second one's driven by the first, so on and so forth. So this is showing that you can drive over 100 feet of Cat5 to an endpoint without any problems. It's actually the very bottom string that's being driven by 100 feet. And if there was a problem, it would be very evident. It would show up. But the two strings are in sync. Actually, all four strings are in sync. And that's just the fact of this test mode, that it doesn't put out different patterns for each one, but it will control each one independently, as shown. One thing you may want to notice is that each one of these endpoints does have the two identical outputs, and I've just wired them up alternately to show that, yes indeed, they're both all being driven. And take note that it's not a split divider. These are individual drivers from the control board there. So this test pattern, you can do quite a few different things. You can change them. You can change the refresh rate. Make it very slow. So that's it for the demonstration of the Pixel Pi board. Hope that you enjoyed it and that you will support me on Kickstarter. Thank you.
We here at Landboards want to thank you for watching our video and hope you'll consider using our product.
This is the RTK GPIO board. It allows you to add general purpose input-outputs to a desktop computer or laptop over USB. At the heart of it is an ARM microcontroller and surrounding circuitry to allow it to speak to your computer over USB and protect it against mistakes. Let's see how to get started. First, plug a micro USB cable into the RTK GPIO board and the other end into a computer, and you're ready to go. You can also use it in conjunction with the Raspberry Pi to be able to have another GPIO header or have multiple add-ons at the same time. Let's look at what you can do. You can control LEDs, display text on a display, control motors with appropriate add-ons, or even connect sensors like a PIR. We are funding the board on Kickstarter to be able to make it a reality. By using Kickstarter, we are able to order the quantity required to get the right price point for you. We hope you enjoy this project and look forward to you back.
Do you, or someone you know, drool over those sweet secret agent gadgets in movies? Do you rip apart your electronics just to see how they work? Do you dream about tinkering with gizmos but don't have the equipment or know-how to, well, know how? Your days of wishing and wondering are over, thanks to the Duino Kit. Designed by a teacher, Duino Kit eliminates small, losable parts, soldering, and many other drawbacks to learning electronics and microprocessor programming in groups or at home. Our exclusive plug-and-play connectors are easily identifiable. Inventing has never been safer or easier. With Duino Kit, you can quickly develop, test, and program new ideas. This self-contained kit helps you build, modify, and hack countless projects like an alarm clock that blinks a strobe light, a burglar alarm, simple memory games like Simon, digital fortune teller, a thirst detector for plants, or how about a love meter?
Hey Kickstarter, my name is Dan Alec. You may remember me in the past couple years with our Duino Kit Junior and Arduino Kit Essentials projects, which we put on Kickstarter and was quickly funded. Those were a prototyping kit based on the Arduino microprocessor And we've been taking that to many different maker fairs, science fairs, engineering festivals around the United States, and the comment I keep hearing from people is they love the Arduino-based kit, however, it would be great if something like that was made for the Raspberry Pi. My response has usually been, we're working on it and it's coming soon. Well, I'm here to finally announce and reveal to you our Raspberry Pi-based prototyping kit. What we did on this kit is we went through and we arranged many different components on the circuit board, and they're soldered to a real circuit board with jumper wire connectors, so you can basically run wires to connect them up to the Raspberry Pi. And we have a manual which includes, right now it's over 115 pages of examples on how to code your projects, on how to hook up the different components, how to get them to work, and also how to do some of the programming and wiring. Another feature that we took advantage of with the Raspberry Pi 3 is its built-in Wi-Fi and Bluetooth modules, and we utilize those to actually broadcast a screen image of the Raspberry Pi onto a tablet. You can also hook your Raspberry Pi through an HDMI cable to a large display, or we'll give you instructions on how to broadcast this image and also touchscreen capabilities to your own device or iPad, Android tablet, personal computer, almost anything you want to be able to hook it up through Wi-Fi and be able to actually view the screen and program the Raspberry Pi via that. Or you could also utilize the USB ports that are on the Raspberry Pi, hook in your own keyboard or your own devices and your extra accessories to start prototyping your own projects. While at the Maker Faire, some of you may have seen this booklet we talked about when we were doing the Raspberry Pi. And what we've been working on is a manual with a curriculum and many parts and projects, so you can learn how to hook up all the different components of the Raspberry Pi. We'll be adding in pictures of the actual Raspberry Pi prototype, or the Raspberry Pi board prototyping kit, so you actually see the wiring on the board, and also images with hookup diagrams for how you hook up the loose components. The nice thing that we made available along with our booklet is we have a loose parts kit. So if you wanted to actually make these projects, you prototype it on the kit and you go, hey, this is kind of cool, I like the way it works. Now you need the parts to prototype it and solder it together. You can actually buy all the loose parts on a kit that we put together, so you can actually solder them up, practice them on the breadboard, solder them together, and actually make your projects as a standalone device. So those kits are also available, and we'll have those in as pledges and reward levels if you just want the hard parts. If you're not interested in the plug-and-play connectors, that's an option, and that will also include this manual. We're looking at getting these in a coil-bound book. It'll probably be about 130, 140 pages by the time we're done, and that will help you get started on how electronics works and how to actually start wiring and building, and also contains all of the code. The code will be available online, so you can copy and paste the code into your Raspberry Pi and get your projects to work. Help with is sharing this project on social media. Share the link on Twitter, on Facebook, tell your friends. If you have a Arduino kit and you're one of the many people that ask me about the Raspberry Pi kit, this is your time to get one. Pledge now so we can get this production underway, get it started, get it manufactured. We should be shipping in August of 2016, so I know it's only a few months away and they'll be coming out real quick. We have all the manufacturers in place from our Arduino kit project, so feel very confident we can deliver this on time and really impress you with what you get. So thank you for your support. Bye-bye.
Once you start learning with the Arduino Kit system, inventions are only limited by your creativity. With online tutorials and a little experimenting, who knows? The next 007 gadget could be invented by you. So what are you waiting for? Order yours today.